हेलो 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 हेलो। हाँ
हेलो।
हाँ सर।
क्लास ले रहे हो?
हाँ
वो एक्चुअली
हेलो 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 हेलो। हाँ सर।
हेलो। हाँ, क्लास स्टार्ट नहीं हुआ है क्या? मतलब वो दिख रहा है लाइट तो ऑडिबल।
ठीक है कर। हेलो गुड आफ्टरनून एवरीवन। हेलो 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 गुड आफ्टरनून एवरीवन। Today we will be discussing about the paper of this month, January mains. So first of all, we have a question. Hello guys, let's solve this question. In this question, we have been asked to find the integration of 2 upon sin x plus sin x into 1 plus cos x dx. So for this particular type, here we can see that this is going from pi by 3 to pi by 2. So what we can do here is integration pi by 3 to pi by 2. So we are doing here multiplying 1 minus cos x. This becomes 1 minus cos square x. So here we can write pi by 3 to pi by 2. Here it will become 2 into 1 minus cos x upon sine cube x, right? Dx. This will become pi by 3 to pi by 2. This will becomes 2 upon sine cube x minus integration of 2 cos x upon sine cube x dx. what I can do here is I can, rather than this, this is not the right approach. So what I'll do here is I will multiply 2 sine x, and this becomes sine square x into 1 plus cos x integration pi by 3 to pi by 2. Now this has become what? Pi by 3 to pi by 2 to sine x dx upon sine square x. I can write sine square x as 1 minus cos square x, and this will become 1 plus cos x dx, right? Now now I can put cos x as t, so I will get minus sine x dx as dt, right? So using this substitution, so for here we will find out when x is pi by 3, when x is pi by 3, cos x is that cos x is cos 60, which will be half, which will be equals to t. And when x is pi by 2, x will be, sorry, cos x will be 0, which will be equals to t. So we will use this substitution. This will write half to 0, and here we will write minus 2t, 2 dt, minus 2 dt upon 1 minus t square into 1 plus t. Yes, so and for this we can change it as 0 to half 2 dt upon 1 minus t square into 1 plus t. Now for this we will use partial fraction. For this we will use partial fraction, and this partial fraction, there is some technical issue here with the sound. Please wait for 1 minute. So we let's remember this thing. In this we will put 0 to half 2 dt upon 1 minus t square into 1 plus t. So we all know for this type of integration we use partial fractions. So what I'll do is I will first of all write 2 upon 1 minus t square into 1 plus t as a upon 1 plus t plus bx bt plus c upon 1 minus t square, right? 0 when it was pi by 3 it is half, when it is pi by 2 it is 0, correct. So now we'll simplify this, we'll get a into 1 minus t square plus b into t plus c into 1 plus t upon 1 plus t into 1 minus t square. So this will get a minus at square plus we'll get here bt plus c plus bt square plus ct upon 1 plus t into 1 minus t square. What we will do here is we will compare the constants and coefficients. We are getting a plus c, a plus c equals to 2, right? These are the constants. Coefficient of t is b plus c, so we will get b plus c is 0, and coefficient of t square is also 0, so we'll get b minus a equals to 0, so we get b equals to a. A plus b is 0, c minus a is 2, and b plus c is 0. So we get a, b is minus a. There is some issue. So we will use this partial fraction technique to solve this question. It is taking a lot of time. Let's move on to the next question. So in this question, as you can see, we can write sine of alpha, sine inverse of alpha as tan inverse of 77 upon 36 plus cos inverse of 4 by 5. So this will be minus. Now cos inverse of 4 by 5 can be written as tan inverse of 3 by tan inverse of 3 by 4, right? So we will substitute that. We will get tan inverse of 77 by 36 minus tan inverse of 3 by 4. So this, in this we can write, we can use the formula tan inverse of a minus tan inverse of b, which is tan inverse of a minus b upon 1 plus a into b. So this will come out to be tan inverse of 8 by 17. This will come out to be tan inverse of 8 by 15. Now tan inverse of 8 by 15 can be written as tan inverse of, we will draw this triangle, we will 8 15, so this was whatever angle, let's say theta. So tan theta is, this angle is our theta, so tan theta is 8 by 15 here, so 8 15 triangle gives here 17. So in terms of sine, it will be sine inverse of 8 by 17. So we will write here in terms of sine, so we will get sine inverse of 8 by 17. So we will get alpha value as 8 by 17. So sine inverse of sine alpha, we know it is alpha, and cos inverse of cos alpha, this is alpha, this is also alpha. So our answer will be 2 alpha, which will be 16 upon 17. Right. So to solve the next question, here we have been given as a bar cross b bar is under root of 46. So what we will do is, we know that a bar cross b bar whole square plus a bar dot b bar whole square equals to a square into b square. Now this is not cross or dot, this is multiplication. Now you will ask here, this is like modulus. So a bar cross b bar is ab sine theta whole square, and a bar dot b bar is ab cos theta whole square. This will come out to be a square b square, right? So this will be this will come out to be a square b square sine square theta plus a square b square cos square theta. So this will come out to be a square b square into sine square theta plus cos square theta. So this will be a square b square. So now we know that mod of this square plus this square is a square b square. Now we know mod of a, right? And mod of a cross b is given root 46. So mod of a bar cross b bar whole square plus a bar dot b bar whole square equals to a square b square can be written as mod of a square into mod of b square, right? So this is actually mod of a into mod of b, and this is given as root 46. So we will write here as 46 plus a bar dot b bar whole square equals to mod of a square will be 14 into mod of b square will be 6. So we will get a bar dot b bar whole square is equals to 14 6 the 84 minus 6. So this we will get as 38. Therefore the question is to find a bar dot b bar whole square. So we are getting a bar dot b bar whole square equals to 38, right? So in this question we are given f of x is a parabola with focus minus half comma 0 and directrix y equals to minus half. So we have to find the number of solution for this particular thing, right? So what we will do is, first we will find f of x, you know, first find f of x, right? After finding f of x, we will use it in this particular thing and then check whatever the solutions are coming up. So to find f of x, what we can do here is to find this particular parabola. We know that when the focus and directrix is given, we can write the parabola as x plus half whole square plus y square equals to, this is y, this y square comes because the focus is given as y minus 0. So this focus is given as 0. So this comes out to be mod of y plus half square upon 1, since the coefficient is 1. So what we have done here is we have just, we have simply, see what we have done here is, you guys must be wondering. So here the focus is given as minus half comma 0. So minus half comma 0 is the focus, and the directrix is the line y equals to minus half, right? This line is the directrix. So the parabola will look something like this, right? So to find the parabola, any point on this parabola is x comma y, right? Any point on the parabola is x comma y. So we know the by the definition of parabola, what I can say is the distance of this point from the focus is equal to the distance of this point from the directrix line, correct? So what I am doing here is we have simply first, so find, to find the distance of this point from the focus, what I will do is x minus of minus half whole square and x2 minus x1 whole square plus y2 minus y1 whole square under root equals to, distance of that point is from the directrix will be, x is 0, so we'll put 0 plus y plus half, and distance of a point from the line, and under root of coefficient of x square plus y square, right? Now when we square this, we will get as x plus half whole square plus y square equals to y plus half whole square, correct? So after simplifying this, what you guys will get is y equals to x square plus x, right? So from this we can say that our f of x is x square plus x. So this is our f of x, which we have found out by finding the equation of parabola. Now here it is given tan inverse of under root f of x plus sine inverse of under root f of x is pi by 2. So what we will do here is tan inverse of under root f of x, which is x square plus x, plus sine inverse of f of x under root of f of x plus 1. Okay, and this is given to us as pi by 2, right? So what we will do here is we can write tan inverse of this thing. So we will draw a triangle. If you want, what we can do is we can, like, let's assume this as theta. So this is under root x square plus x, so this is 1. So this becomes under root x square plus x plus 1. So we can write this as cos inverse of 1 upon under root of x square plus x plus 1 plus sine inverse of under root of x square plus x plus 1, and this will be pi by 2, right? Now we know that here by this we can use pi by 2. We know that sine inverse of alpha plus cos inverse of alpha is always pi by 2, right? So we can write as cos inverse of alpha equals to pi by 2 minus sine inverse of alpha. So using this property, here I can write as cos inverse of 1 upon under root x square plus x plus 1 plus, sorry, equals to pi by 2 minus sine inverse of under root x square plus x plus 1, right? So this thing can be written as cos inverse of under root x square plus x plus 1, correct? So what we will do here now is, we know that we have found out that cos inverse of 1 by under root x square plus x plus 1 comes out to be cos inverse of under root x square plus x plus 1. So for this particular thing, when cos inverse of this is equals to cos inverse of this, we can say that these two particular terms expressions are equal. So I can write it as 1 upon under root x square plus x plus 1 equals to under root of x square plus x plus 1. So from this particular thing, we can find out that x square plus x plus 1 comes out to be 1, right? We have just cross multiplied this. So here we can get x square plus x is 0. So we get is x into x plus 1 is 0. From this particular thing, we can say that x is 0 or x is equals to minus 1. So for after solving this, we see that for two particular values of x, that equation is satisfied. Hence, we can say that we have two values of x for which the equation is satisfied. So we can write our answer as 2. So the number of solutions for x So the number of solution for x is 2. Now to find the for this question, we have been given f of x is x plus mod of x upon 2. G of x is x when x is negative and x square when x is positive. What for to find f of, we are supposed to find f of g of x. So what we will do is, this means f of g of x, right? So when x is negative, let's make two condition here as well. When x is negative, we'll simply put x in place of this. So this will become x plus mod x by 2 when x is negative, right? And when x is positive, this will become x square plus mod of x square by 2 when x is greater than equals to 0. So we have found out f of g of x, right? And now we have to find out the area bounded by f of g of x with the line 2y minus x equals to 15. So first of all, let's write down f of g of x clearly. So this is what, when x is negative, we can write mod of x is minus x, correct, upon 2. So this is what, when x is negative. And x square plus mod of x square can be written as x square upon 2. So x is greater than equals to 0. So this thing again comes out to be f of g of x will be equal to 0 for x is negative and 2x square by 2, which will be x square when x is greater than equals to 0. Now if you draw the graph for f of g of x, so it is 0 for x is negative, so y equals to 0 is the line. So this is, let's take another color pencil. I'm taking greenish. So this is the line when x is negative, right? X negative means towards the left side of y-axis. Now for x positive part, for the part where x is positive, let's take some other color, blue, and we know that the graph of x square looks something like this. It is a parabola passing through the origin, right? So for x equals to positive, we will only consider this graph. And now the line equation that has been given to us is 2y minus x equals to 15. So the line equation is 2y minus x equals to 15. Let's find out the coordinates like intercepts and we will draw the line. So this we will put 2y minus x equals to 15. So this line will be what? When x is 0, we get y is 15 by 2 and x is 0. And when y is 0, so we get x equals to minus 15 comma y equals to 0. So x is minus 15 comma 0 here somewhere, minus 15 comma 0 and 0 comma 15 by 2. So the line will pass. I am taking this point as this point as 0 comma 15 by 2. We have to find the area bounded by this particular figure. This line, green line, this dotted line, and this parabola x square on the positive side. So we need to find out this point of intersection, right? We need to find out the point of intersection. So what we will do here is I will substitute the value of y in x square. So what we will do, we know y is 15 plus x upon 2, right? And we will substitute in this particular thing. Here we know uh, 15 plus x upon 2 is should be equals to x square. So we will find out 15 plus x is 2x square. So 2x square minus x minus 15 equals to 0. So we know here that 15 to the 30 and 6 5 are 30. So I will write 6x plus 5x minus 15 equals to 0. I'll take 2x common. I'll take 2x common. It will be x minus 3. Here we will take 5 common. It will be x minus 3 equals to 0. So we will get two coordinates. First will be x equals to minus 5 by 2 and the other will be x equals to 3. So for f of g of x to be defined as x square, x is positive, right? So we will take the positive value and this point will be 3. And we know that when x is 3, y is 9, right? So this point is 3 comma 9. Now we have all the required points to find the area. So first of all, we'll find out this area of the triangle, this triangle between the green line, y-axis, and the given dotted line, which is 2y minus x equals to 15. So we will find this area 1, this will we will name as 2. So we will find area of 1 plus 2, right? So to find the area of 1, first of all, let's find the area of 1. It will be half into base into height. So base is 15. As you can see from origin, this point is 15 units away and height is 15 by 2, right? So we get area as 225 upon 4. So this is our area of 1. Now for area of 2, what we will do is we will integrate this line. First of all, let's name this as f of x1, and this is our f of g of x, right? So we will f of x1 minus f of g of x dx. From where to where? X coordinate is changing from 0 to 9, 0 to 3. So we will write 0 to 3. F of x1 is 15 plus x by 2 minus f of g of x is x square. So we will write here dx. Now integration 0 to 3, 15 plus x by 2 minus x square dx. Here what I will do here, this is simple integration 0 to 3, 15 by 2, integration of 15 by 2, this we can write as 15 plus x minus 2x square dx, and 1 by 2 we can take outside. So integration of 15 is 15x plus x square by 2 minus 2x cube upon 3. So this comes out to be 0 to 3. We will put 3. So this will get us 15 into 3 plus 9 by 2 minus 3 cube. It is 3 cube is 27. 27 upon 3 is 9, and 2 9s are 18. Right. So we will get here as 45 minus 18 is 27 plus 9 by 2. This we will get as 63 by 2. So our area 2 is this value. So we will sum 1 plus 2, we will get as 225 upon 4 plus 63 upon 2. Right. So this will be 225 plus 63 2 is 126. Upon 4. So this comes out to be 351 by 4. Thank you guys for the session.